Doobie-doobie-doo, last 5 questions. All right, number 21. The pressure of a gas varies inversely with its volume. Use the formula P equals 659 over V to find out the pressure in milliliters of mercury is what that means. Millimeters of mercury. It's a measure of pressure. And it's a U. You don't really need to know that for the problem. It's just a bit of information. When the volume is 47 liters. So they tell us the volume. We're looking for the pressure. All you gotta do is take 47 and put it in for volume. So this is a rational function, but you don't really have to do anything with rational functions to figure this out. Just plug in 47. So P equals 659 divided by 47, and just put that in your calculator. So the pressure, let me put that on a new line. Pressure equals 14.0213 millimeters of mercury. That's it. Easy enough. 22, list the transformations. We got another transformation one. So I got vertical reflection, left 4. This is a horizontal reflection, because it's inside with the X. Down 1. Now this, okay, so this is where people get confused. This is a number between 0 and 1. So 0 is less than 2/3, is less than 1. That means it's a vertical compression. So you see a fraction in front like that, it's going to be a compression, or a decimal like 0.5. And this right here is another left 1, up 21. Then this one we've got a vertical reflection. The 2 is a vertical stretch. That's commonly forgotten. So the negative and the 2 are separate. The negative reflects it, but the 2 stretches it. It makes it twice as tall as it would have been originally. So you got both. And then right 1. And then we got vertical compression here because it's 0.5, so it's half as tall, so it's getting squished. Think of it that way. It's a compression. And then up 9. 23, give the domain and range of each function below. If you don't remember these, I would suggest graphing them all. So here's A. You may want to add a grid. View, grid, line grid. Makes it a little easier to see sometimes. So my domain, so my x's, I want to go left to right. What's the leftmost I can go on this graph? Well, on the screen it's -10, but of course the graph keeps going that way. It's not going to end just because my screen ends. It would really keep going. So I'm all the way to -infinity there. And then on the right, it doesn't just end at like 1.5. It keeps going. It's going to slant, but it's going to keep getting slowly more to the right. So my domain is going to be all real numbers. My range, on the other hand, it's exponential function, so I've got a horizontal asymptote here. That means my graph does not go below this number, which is -2. So my y values cannot be less than -2. However, they can keep going up, so my y values can get bigger. So I might say y is greater than -2, or I could say -2 to infinity. And that's not an ordered pair, it's just interval notation. So you might say it either way. And B, B is a quadratic, and I know some of you are going to call me over saying, Miss, it didn't show up. Well, that's because it went up 13. And my graph only goes to 6.67, so you're going to have to... Now it's letting me move it. An earlier problem didn't want to let me move it. You're going to have to move it so you can see it, either that or zoom out. So quadratics always have a domain of all real numbers, unless you're talking about some word problem context, but we're not. And the range you'll see is, so 13 is the lowest that my y values can go, but they can keep going up forever. So I want to say y is greater than or equal to 13. This has an equal to where the last one does not. This was an asymptote. This has an actual point. And then for interval notation, I can go from 13 to infinity. So either way you want to see it. Remember, the bracket is for if you are including the number, parentheses if you are not including the number. So here, see, and again, some of you are going to say, Miss, I can barely see the graph. And that's because it moved down 7. That's down 7, so you're going to have to move your window. It's just how it is. Sorry. That's logarithmic. So, of course, logarithmic functions have a range of all real numbers. Domain we'll check in a second. Range, we know it's all real numbers. Then you got to find your vertical asymptote, which is at -1. So the furthest left I can go on this graph is -1, but I can keep going to the right. So my x's are all greater than -1. So x is greater than -1, or you might see -1 to infinity, kind of like that one was for the range. And then do you have a square root? No, I want equals. Oh my god. X plus 2. Because here's D. And I just didn't move my window from what I had it for C. So anyway, that works. So square root functions have either a beginning point or an end point. So first let's look at my x's. What's the leftmost I can go? Well, my leftmost point on this graph is at -2 for the x value. So my domain is, you can either say -2 to infinity, or you can say x is greater than or equal to -2. For the range, the smallest y value. So let's see, -1, -2, out of the way, -3, -4, -5. So I can go -5 to infinity, or I can go y is greater than or equal to -5, either way. 24, what is the solution of log of x plus 1 equals log of -3x plus 13? So notice I've got one log on each side. I don't have to use product rule. I don't have to use quotient rule. I don't have to use power rule. Don't even have to do reverse PEMDAS just yet. First, I can cancel both logs out. And then I get x plus 1 equals -3x plus 13. And I got to cancel the x's either from the right or from the left. And it really doesn't matter, but I'm going to go ahead and cancel this one because then my x's will be positive, and I kind of like it like that. So a -3x is going to be canceled by adding 3x. So x plus 3x is 4x plus 1 equals 13. And then I can subtract 1 from both sides. Yeah. So 4x equals 12, and then divide by 4. X equals 3. And then you do want to make sure that you're not going to get no solution there, so plug it back in and see. I went ahead and plugged it into the whole thing, and it came out true. There's no solution, so we're good to go. Finally, number 25, what is the solution to this equation? Now notice where the x is again. When your x is in the exponent, you're going to have to use a log to solve this. So first, though, we got reverse PEMDAS. So can you add or subtract anything? Well, sure. Add 8 to both sides. 2 to the power of x plus 9 equals 24. Now, I don't have anything to multiply or divide in this problem. So I'm on my exponent step, which means I need to write it as a log. So remember, I have base, and then I have my exponent equals my argument. And to convert that, that's going to give me log base whatever of my argument equals my exponent. Okay, so make sure everything goes in the right spot. So my base becomes a subscript. So log base 2. And then this part, the argument, is the one that initially is by itself, and then it goes in parentheses. So 24 equals, and then the exponent ends up by itself, which is the whole point. That's why we're doing this. That's why we do a log. So put this in the calculator. And you get 4.58496 equals x plus 9. And then just subtract 9 from both sides. And you get x equals negative 4.41504.